Hello, everyone. Welcome to another brief lecture for our Phil 115 critical thinking material. This is chapter 5, which focuses on inductive arguments and statistics. While we won't go into some of the more formal details of statistical analysis, hopefully we can appreciate why knowing a bit more about inductive reasoning can make us better critical thinkers. So, thus far, as I'm sure you've noticed, we've discussed mostly deductive reasoning, which provides logical support for areas like mathematics, artificial intelligence, computer science, law, and other disciplines. Inductive reasoning, by contrast, though, gives us most of what we know about the empirical workings of the world, allowing us in science and in ordinary experience to infer reliably from what we know to what we don't. And one point of notation here is that inductive reasoning, the kind that we do on a daily basis, especially as it concerns predictions about the future or comparisons between things, this seems to be the kind of reasoning that we do even more often than deductive reasoning, I think it's safe to say. It doesn't mean that one is more important than the other, but I think it is fairly obvious that we use inductive reasoning in lots of different cases, even unknowingly, on a much more regular basis. And it's the kind of reasoning that allows us to go from essentially what we know to beyond the evidence, to infer about what's already known to things that are probably true about unobserved cases. So, for example, when we talk about probability, we enter the realm of statistics. Our goal is to discuss some forms of inductive arguments and how to evaluate them. And we'll discuss some philosophical issues with induction. And we'll note that one of the most famous arguments for God's existence is an argument by analogy. So there's a lot packed into this chapter, but hopefully we can appreciate why knowing a bit more about inductive reasoning can make us better critical thinkers. Okay, so one of the first, if not the first argument form or reasoning type that's mentioned in the chapter is called the statistical syllogism. So here, this is an inductive argument pattern in which the inference goes from a statement about a group of things to a conclusion about a single member of that group, which we do all the time. Okay, so simply, by example, if we said something like, most politicians are liars and Anthony's a politician, so Anthony is also probably a liar. So what are we doing here with this kind of reasoning? We're making a claim about all of some group of people, in this case, politicians, being liars. And then we point out that I'm a politician. And so what do we infer? Well, we infer that a single member of that initial group is also a liar, has that property. So a statistical syllogism usually goes, as we just kind of alluded to, if we're going to formalize it, it's usually going to look something like this. It's going to be less than a universal claim about a group. Now, why is that? Well, if it's a universal claim about a group, now we're in deductive reasoning territory, right? So if you recall back to deductive reasoning, if I said all men are mortal and Anthony is a man, therefore Anthony is mortal, that follows necessarily, right? So that's deductive reasoning, because the conclusion is intended to follow necessarily from the premises. But in statistical syllogisms or syllogistic reasoning, we're making a less than universal claim, like a lot or most, some claim about some group or target, and then we note that some individual is a member of that group, and then we infer that that member has that property in question. Another kind of very common inductive reasoning type that we use quite regularly is called enumerative induction. And this is an inductive argument pattern in which we reason from premises about individual members of a group to conclusions about the group as a whole. So maybe one way to think about this is, instead of going from the group to an individual, we're arguing from specific cases to then generalizations about groups as a whole. We do this all the time. And in fact, I think this is a really good example of the kind of reasoning that people don't really do very well. So good examples would be things that we've already talked about, like stereotyping and hasty generalizations, right? Where we use insufficient sample sizes to make hasty generalizations about entire groups of people. But it doesn't mean that all instances of enumerative induction are bad. Certainly it can be done, well, but we really want to be careful about sample sizes, which we'll talk about in a second. So usually it has this general pattern, right? Some percent of observed members of some group, call it A, has property P, therefore some percent of all members of group A probably have that property P. So, I mean, we can make sample arguments out of this in so many different ways, right? If we said most Samsung Galaxy Note 7 smartphones observed so far have caught fire, therefore all Samsung smartphones catch fire, that's enumerative induction, right? Because we're arguing that some percentage of observed cases, whether it's most or a lot, 90%, whatever it is, thus far have caught fire, therefore they're all going to catch fire, right? Or it could be as simple as, the last 98 apples I've tasted out of this barrel have all been bad, therefore the remaining 2 are going to be bad, right? So we use this kind of reasoning all the time about products, about groups of people. And the question is whether or not we can make a strong case or if it's going to be a weak case or a weak argument. So enumerative induction usually has the following form. Some claim about observed members of cases to a claim that all or mostly all members have that property. Okay, so just a couple important terms that are mentioned in the chapter. So one helpful notion is what we call the target group. This is often called a target population in polling, where we use this term quite frequently. So in enumerative induction, it's meant to capture the whole or intended collection of individuals under study. So when we're polling, for example, when we take polls, our target group is usually groups like Americans or eligible voters or registered voters or people of a certain age group, right? That would be the target group. That's the group that you're trying to sample. Hence our next term, sample or sample member. In enumerative induction and statistics, this is the observed members of the target group. These are the people that, quote unquote, we've sampled or called or polled, right? These are the observed members that we've, given the survey to, things like that. So we have a target group, a sample, and then we're trying to ascertain the relevant property or property in question. So in enumerative induction, a property or characteristic that is of interest in the target group. So with polling, it could be, who are you voting for in 2020? Joe Biden or Donald Trump or someone else, right? That's, we're trying to get a percentage of where people are at or what they think about some topic, right? That would be the relevant property in question, depending on the purposes. Okay, so let's just look at a simple example and see if we can apply the terms that we just talked about. So all the corporate executives Jacques has worked for have been crooks. Therefore, all corporate executives are probably crooks. So we can ask here, what's the target group? What's the sample and relevant property being claimed here? So the target group here is what? Corporate executives. That's who this argument is referring to. It's making a claim about corporate executives. What's the sample? Well, the corporate executives that Jacques has worked for. That's the sample that have been observed. What's the relevant property? Being a crook, right? Now, then the question is this a strong argument? I think the answer is no, because this is purely anecdotal experience. And more importantly, this is a hasty generalization, which we'll talk about a little bit more in the chapter on fallacies. But, right, Jacques has worked for what, maybe, if we're being generous, a couple of corporate executives. Is that a good inference to then claim that all corporate executives are crooks? That seems like a stretch. So that would be a weak argument, I think, pretty clearly. Okay, so we just went over this, right? This falls short. The sample is way too small here, as we just mentioned. We simply cannot draw reliable conclusions about all corporate executives based on a mere handful of them. So the argument would be weak. So we want to make sure and use the right terminology when we assess inductive arguments versus deductive arguments. Okay, so a few more terms came up here. Some of you might have already discussed this in a math class or a stats class or some other class at the college. But as we just mentioned, hasty generalization, this is the fallacy of drawing a conclusion about a target group based on an inadequate sample size, right? So for example, if we made the argument, two of my college roommates were physics majors, and they were both incredibly boring, therefore all physics majors are boring, that's a hasty generalization, right? A biased sample is a sample that does not properly represent the target group. And this can be done in a number of different ways. Rather, what we look for, or at least we hope to look for, is samples that are representative. So in enumerative induction, a sample that does resemble the target group in all the relevant ways. So the book goes into some examples of how to use non-biased samples and ways that samples can be problematic. Okay, so another thing that we tend to really value, especially in polling and statistics, is random sampling. So why do we prize that? Well, this is a sample that is selected randomly from a target group in such a way as to ensure that the sample is more likely to be representative of the target. So in a simple random selection, every member of the target group has an equal chance of being selected for the sample. So what's an example of this in practice? Well, if I'm sampling Americans or Washingtonians for whether or not they support some political issue, if it's truly random, then I'm going to randomly select which people I call. If I only called, people that I know, or people that live in my area, that's not a random sample of Washingtonians, right? That's going to be a bias sample. A much more random sample would be right, every third person, or and do it enough times to where I'd really get a much more representative sample for so many different reasons, right? So we prize random samples because they give us we think and hope, a much more accurate sample of the target group. Another term that's mentioned that's a bit more mathematical, but we don't need to go into all the details, is the confidence level. Sometimes this is referred to as confidence interval. And in statistical theory, this is the probability that the sample will accurately represent the target group within what we call the margin of error. And the margin of error is the variation between the values derived from a sample and the truth values of the whole target group. So we could tell a much more thorough story in statistics, but we'll leave that for another class. Okay, so let's just do a little practice. We'll do this on the quiz and even exams. We'll be given an argument. So for the following enumerative induction, we want to identify the target group, the sample, relevant property, indicate whether the argument is strong or weak. And if it's weak, say whether the problem is a sample that's too small, not representative, or both. And let's assume that the premises are true. Okay, so how about this one? 2/3 of the adults in New York City identify themselves as pro-choice in the abortion debate, and almost 70% of adults in San Francisco do. This makes the situation perfectly clear. A large majority of the people in this country identify as pro-choice. So I would encourage you to pause the video here and see if you can answer 1 through 3 for this argument. Okay, so what's the target group? People in this country, or we could just say Americans, right? Because it's being cited here, especially in the conclusion. So the target group is people in this country, or Americans. What's the sample? Who's been polled? Adults in New York City and San Francisco. What's the relevant property being invoked? Being pro-choice in the abortion debate. Is this a good argument, though? So we should notice, if you know a little bit about American demographics and geography, you'll know that these are two of the more liberal cities, if we're using political ideology to these cities. And right? There's a lot of people that don't live in New York City and San Francisco in the US, and those aren't going to be representative samples, right? So this is going to be a weak argument. The sample is not representative. We would need to poll people who live in other cities and other states, right? And maybe more rural areas and places not just on the coast, right? So I think this is a good example of one that's clearly weak. The sample is not representative of the target group, which is supposed to be people in this country. And if we've just polled 2 cities, that's not really going to give us a representative sample. Okay, so let's do the same thing here. I've asked at least a dozen first-year students at this university whether the US should go to war with terrorist countries, and they all have said no. So most of the students at this university are against such a militant policy. So again, how would we assess this piece of reasoning, this argument? Well, the target group is what? Students at this university. The sample was first-year students at this university. Relevant property, being against such a militant policy. This is also weak because the sample is both too small and not representative. Why is it too small? Well, I've asked at least a dozen. I mean, how many people go to that school? Probably quite a few thousand. So a dozen students, that's not a big sample size. That's not an adequate sample size. And it's not going to be representative for a couple different reasons. There's more than just first-year students, right? Yeah, there could be other factors for representative, but it's pretty clear that a dozen first-year students is both too small and not representative. So this is a weak argument. Okay. So an important point here, this really crops up, especially with the rise of social media. People misusing polls and statistics. So one way that the internet does this is by, or people do this, is by using self-selecting samples like website opinion polls. So if you go to a website, for example, I'll just make something up, and it is, we'll use sports, like the Seattle Seahawks. If you go to a Seattle Seahawks fan website, and you take a poll that asks, what's the best player or who's the best player on the team, is that going to be a very representative poll? No, because who's going to that website? Seattle Seahawks fans, right? So self-selecting samples and opinion polls on websites are usually self-selecting because these are the types of samples that tell us very little about target populations, whether it's the US population or adults, because you're self-selecting. You're already a member of a group that would take that quiz or poll anyway, right? So we would get a self-selecting sample if, for example, we published a questionnaire in a magazine and then asked readers to fill it out and mail it in, or if during a TV or radio news broadcast, we asked people to cast their vote on a particular issue by clicking options on a website or emailing their responses, right? There's lots of different ways that self-selecting samples get used and manipulated to stand for target groups when they really don't do that, or they're not justified statistically. So we want to be very careful and good critical thinkers when it comes to self-selecting samples. All right, so I already mentioned the hasty generalization, which is drawing a conclusion about a whole group based on an inadequate sample of the group, right? There's another example of a hasty generalization. We'll also talk about faulty analogies, because one of the other big forms of inductive reasoning that we use all the time is arguments by analogy, or analogical induction, I think as the book calls it. And we often give faulty analogies where two things that are being compared aren't sufficiently similar in relevant ways to make the conclusion follow from the premises. So here's a silly example. Dogs are warm-blooded, nurse their young, and give birth to puppies. Humans are warm-blooded and nurse their young, therefore humans give birth to puppies too. That's obviously drawing the wrong conclusion there, right? That's a bad analogy. Okay, another way that online statistics can be manipulated or misleading is by equivocating the word average. So importantly, average can come, as I'm sure some of you already know, can come in 3 different forms, and those numbers can be quite different. So in average, oftentimes news stories won't specify whether they're talking about the mode, median, or mean. And that's important, right? Because the mean is the average of a set of numbers, right, that we determine by adding up all the values and dividing by the number of values added together. The median is the exact middle point of a series of values, and the mode is the most common value. So anecdotally, one example I see of this all the time is when news articles talk about a couple things, notably home prices and average salaries. So that could really change. So take the latter case, average salaries. I mean, if you do mean versus median, you're going to get very, very different answers. So especially if you include high earners like Bill Gates and Jeff Bezos and Elon Musk, that's really going to change the difference between the numbers of median and mean. So it's really crucial to specify which version of average that you're using to give the reader a better understanding of what how those numbers are being calculated, because depending on which version you're using, that could really give you different answers. Also with home prices, right? Because if most of the homes being sold in the area sell for 200, 300,000, but then in some other part of town you have multi-million-dollar homes, then of course the the median point, if that's being used as the average, is going to be much higher than the mean. So just be critical of articles that use averages and don't tell you how they calculated it, because that could be misleading. Okay, so if you want some practice, I would encourage you to find the mean, median, and mode for the following set of numbers. Okay, so the mean would be 5.28, the median would be 6, and the mode would be 3. So obviously not a huge difference here, but again, going back to some of the examples I just mentioned, this could really be quite different. All right, so it really does matter how we're calculating average when higher numbers are involved. Okay, so to kind of wrap things up here, inductive arguments, especially ones that use opinion polls, should be strong and have true premises, right? They should be cogent. More precisely, any opinion poll worth believing must, 1, use a large enough sample size that accurately represents the target population and all the relevant population features, and 2, generate accurate data. The results must correctly reflect what they purport to be about. And ideally, they should report their metrics, how they've calculated it, who the firm is. Some polling places are better than others. And a poll can fail to meet this latter requirement through data processing errors, botched polling interviews, poorly phrased questions, and the like. So the book does a good job of talking about the many ways in which opinion polls can be heavy-handed, can ask misleading questions, lots of different ways that opinion polls in particular, can go wrong. All right, so lastly, we want to mention perhaps the most common or one of the most common forms of inductive reasoning, arguments by analogy, also called analogical induction. So these are the arguments that we use where we make use of an analogy or comparison between things, reasoning that because 2 or more things are similar in several respects, they must be similar in some further respect. And it usually has this format. Some thing has properties P1, P2, P3, plus the property P4. Oops, sorry. Thing B has properties P1, P2, and P3. Therefore, thing B probably has property 4. To put it more colloquially, it's whenever we compare 2 things and say, well, because they have these things in common, they must also have this thing must also have this other thing in common. So here's a simple example. Being a successful college student requires dedication, commitment, effort, and also attention. Being in a monogamous romantic relationship also requires dedication, commitment, effort, and time. So being in a monogamous relationship also requires attention, right? So what are the 2 things that I'm comparing here? Being a successful college student and being in a monogamous romantic relationship. I'm comparing 2 things and saying that because they have these things in common, one of these things must also have this other thing in common. And we use analogies all the time, right? To compare things or to argue that one thing's better than another. It's a pretty common form of inductive reasoning. So let's list a couple of criteria for judging arguments by analogy, because analogies are used quite regularly, especially online. So number one, the number of relevant similarities. How many things do they have in common, right? Because the more things they have in common, typically we think the analogy is stronger. And also we need to ask, how are they dissimilar? Because if the number of relevant dissimilarities far outweighs the number of relevant similarities, then obviously we think, or we should think, that the analogy isn't going to be as strong and the argument is weak. How many instances have been compared, right? If I've only compared one romantic relationship to one college student, that's not going to be a great analogy, right? Whereas if we're considering more instances of it or more instantiations of it, then we think with any hope the conclusion will be better supported. And the diversity among cases. Are they not just similar cases, but a diverse set of cases? Because obviously the greater the diversity of the cases, the stronger the argument, we hope, is going to be. So the book talks about the diversity of cases, I think, at the end of the chapter, right? Yeah. Okay. So let's practice evaluating an argument from analogy. So let's indicate the things being compared, the relevant similarities mentioned or implied. 3, whether diversity among multiple cases is a significant factor. What's the conclusion, and whether the argument is strong or weak. Okay, so like former President Ronald Reagan, President Underwood, that's from the Netflix show House of Cards, by the way, is a staunch conservative, has strong religious values, and adheres almost dogmatically to certain principles. President Reagan allowed his fierce fidelity to his principles and values to lead him into foreign policy disaster, the Iran-Contra disaster. President Underwood will likely be involved in a similar foreign policy mess for similar reasons. So there's a comparison here. So let's try to answer 1 through 5, if you can on your own first. Okay, what's being compared here? The personality traits of Ronald Reagan and President Underwood. What are the relevant similarities? Well, they're both supposed to be staunch conservatives, strong Christian values, almost dogmatic adherence to certain principles. Diversity among cases is not really a significant factor because we're comparing 2 specific American presidents. What's the conclusion? President Underwood will likely be involved in a similar foreign policy mess for similar reasons. This seems like a weak argument, right? There's so many unmentioned dissimilarities that there really doesn't seem to be a strong analogy being made here. Now, these arguments, people are going to disagree, right? Some people are going to think a strong analogy is being made. Some people are going to think that it's weak. That's okay, right? But we have to have some shared notion of what should count as a strong versus a weak argument. And reasonable people can disagree, of course. But most all of the examples that we'll look at, either on the quiz or exam, it should be pretty obvious that the reasoning is either strong or weak. Okay, how about this one? A well-established moral principle is that one is morally justified in using deadly force in self-defense when one is threatened with death or great pain from an assailant. A disease such as terminal cancer can also threaten one with death or great pain. So suicide, a use of deadly force, must sometimes be morally justified when it is an act of self-defense against an assailant, terminal disease that threatens death or great pain. So this is a rather bizarre argument, but an analogy is being made between self-defense with deadly force and using suicide as self-defense against a terminal disease like cancer. People make arguments of all shapes and sizes, right? So let's see if we can answer these. What's being compared? Having terminal cancer, being threatened by an assailant. What are the relevant similarities? Being threatened with death or great pain, right? Those are supposed to be the case in both instances. What's the conclusion? Suicide must sometimes be morally justified when it is an act of self-defense against a terminal disease that threatens death or great pain. Now, I've always picked this example. Vaughan, our textbook author, thinks this is a strong argument if all the relevant similarities and dissimilarities have indeed been taken into an account. I think you can make an equally strong case that this is a weak argument. And I would think both answers are equally good because, I mean, there's just so many differences, right? Dissimilarities between using self-defense to protect against an assailant and committing suicide to protect yourself from, which isn't even really protecting yourself in the same way, right? But so, I mean, I think you can make an equally strong case that killing oneself in self-defense is just not relevantly similar to killing another human in self-defense, right? And then we could specify what the significance is. So I picked this example too because it illustrates that, you know, not everyone's going to agree on the strength of inductive analogical arguments, but as long as you give good reasons to support your answer, then that's what's most crucial. So I think this one could go either way, but some arguments I think just are objectively strong and weak. That much should be clear. Okay, and the last thing that I'll mention in this lecture that's already gone a little bit too long is the gambler's fallacy. This is one of my favorite forms of inductive reasoning to observe and to think about because people are really bad at, well, I want to be charitable. People just, when money is involved, people are really bad at reasoning well, especially when it comes to gambling. So the gambler's fallacy is quite a common phenomenon. So if you're unfamiliar with this game, this is called roulette. It's available in most all casinos around the world. Pretty common, popular game. So a roulette gambler thinks that, well, let me set this up a little bit more. If you go into like a casino in Las Vegas or even some around here in Western Washington, you'll notice that there's a board and it will display the last 10 or so spins. And gamblers can bet on black or red, odds, evens, a series of numbers, things like that. But one of the reasons that they installed boards is because they know, the casinos know that people commit the gambler's fallacy. So you go up to a table and it says the last 12 spins have been black. What do you think people are going to bet on? They're going to bet on red, right, for the 13th spin. Why? Because they think, well, red's got to come up at some time. So the problem with this reasoning, though, is that the probabilities haven't changed. The probability of landing red or black is still it's about 46 to 48%, depending on what kind of wheel you're playing on, if there's 0 or double 0. So the probability of red or black has not changed. We call those events independent in probability theory. But they're also claiming that past spins affect future results. So the gambler's committing a fallacy here. They think that both the wheel is fair and not fair because they think that past spins affect future spins, which isn't the case, right? And so they think red is going to be due next time, right? So the gambler is being inconsistent. They're arguing that the setup is fair, but there have also been 12 black spins in a row, so red must come up next, right? That's not good reasoning. So we use this kind of reasoning, unfortunately, all the time. And it's one of the many reasons that casinos make a lot of money off of us, okay? The conclusion that would follow, we would think, is if it's been 12 blacks, that it's going to be another black, if anything, assuming the setup isn't fair. But this conclusion that red must turn up next would only follow if and only if the outcomes were not independent. In other words, that past spins would affect future spins, but that's not the case. So the gambler is being inconsistent. That's why we call it the gambler's fallacy. So that's one of my favorite fallacies. So let me leave it there. I know I've gone over a lot, but if you have any questions, as always, please reach out to me. Thanks for listening, and I'll see you next time.